Hello, everyone.
Good morning.
My name is Maxim Uvarov. I am senior engineer in Linaro in networking group, and my colleague is...
My name is Dmitry. I'm a senior engineer in Cavium, and I'm an assignee to Linaro.
Okay. We will talk about complex testing in a project in Travis. As an example, we will show how we test ODP. It's an open data plane project, but these ideas and this experience can be used to any project which use auto tools, which is user space project. So we will just show why testing is complex and why you need continuous integration and how it's easy to use Travis and GitHub integration. So a few words about what is Open Data Plane. Open Data Plane is open source set of API for networking. So we have a Git tree in GitHub, and we provide reference implementation for Linux generic platform. You can use this reference implementation just to run on any Linux, any distribution of Linux like Debian, Ubuntu, CentOS. It has to compile and has to work. You have run examples, run tests, and you can play with it. So this tool is used auto tools. It's a C99 language. We support different platforms, x86, ARM, ARM64, MIPS, PowerPC, and we run continuous integration in Travis, and that saves a lot of time to maintain this project. So we trying to accept patches which already passed continuous integration, so they can compile and they can run. So our project, as I said, is on GitHub. We reference implementation consists static library and dynamic library, examples, tests, and documentation, which is generated with Doxygen from source code directly. So what is the Travis? Travis is service which you can enable with adding .travis YAML file, which consists some scripts. If you have this file with your repo, your repository is hosted on GitHub, then on each Git push, Git pull request, you will run automatic test. You will have run automatic tests, and as the result on web page there will be a status which will show if test passed, if it failed, and according to that you can take a decision what to do with this patch or pull request, or so
whether to merge it or not at this point.
Yeah, thank you. So Travis has different features which might be not very popular, but they exist, and if your project is complex, it's better to use it. So features is like you can run in parallel several tasks to speed up your CI process. You can have network access, you can download, upload files from internet, you can have root access, and you can build a really big complex test matrix. So as I said, to trigger Travis build, you need to push travis.yml file. Then on each push request to your local Git or to pull request to mainline Git, Travis will trigger its work, and we can just see what's going on with this change. Also, Travis can be run on as cron job. So using Travis, we will not need git bisect, so it will use very rarely. So if you need to find which exactly commit broke the build, you can go to web page and see which commit passed all test and which commit failed test. So that's quite easy.
Yeah. The Travis configuration is well, I will speak about C and C++ projects in Travis, because Travis also supports obscure things like Ruby gems, Java projects, etc. So Travis build system, Travis testing system depends on the build matrix. You define a set of compilers that will be used by your project, and you define a set of environment settings. And depending on this, Travis builds the so-called build matrix. So for each compiler, it will test all the environment settings that you have set up in your Travis configuration. I will show the details later. It's possible to add additional jobs one by one, which we used to enable single specific tests in our configuration. We started as a simple Travis configuration, then we added cross-compiling tests because we required them to really check that our project works and can be compiled for different platforms. It was possible to do that in Travis thanks to it using Ubuntu Trusty system as a main image for the build system. That already contains cross compilers for ARM, 32, ARM 64, and PowerPC. So let's go to the gory details. We started with 2 compilers, which means CLang and GCC, and 4 variants, 4 environments, as I said. We had the default one, we had several schedulers that can be used internally, and we were using a special configuration to enable or disable ABI compatibility. So it's, as I said, gory details of ODP project, but just 4 details. And then we started adding more and more build variants and more tasks, like cross-compilation for all these platforms, and each cross-compilation goes on with both GCC and CLang, and special tasks for to test the Doxygen documentation, that it builds without any warnings that there are no omissions from the docs, like check patch to test that all patches are really following the coding style of the project, and so on and on. And this was going on until a single build was taken up to the 4.25 hours. Yeah, for a really small project. So this is an example of the build matrix, 2 compilers, 4 configuration settings that we later pass to a configure script, and we show an additional job as a cross-compilation job. So, the matrix will be built by Travis from the compilers and environment, and jobs includes additional jobs. And this is how it resulted in the in the Travis web page. You see several matrix jobs, and then goes cross-compiling jobs added manually, then several tests like code coverage, discheck, Doxygen, and check patch. Yeah. And this is already after some optimization that Maxim will tell later, but at the...
It's actually for each patch, for each single change, we run all this complete set of tests.
And after going to the web page, you can see that if any of these tests pass or fails, you can go and check where it fails, what are the messages, and so on. So you can check everything. This is just an example of what are we doing with Travis. Different checks, different source code checks, including validation, including performance tests, including examples, and that is running on different platforms, both using CLang and GCC. So, did we forget anything? Yeah, in fact, yes. We planned to support MIPS, and as a source tree, we do support MIPS. But unfortunately, Ubuntu Trusty doesn't have cross-compiler for MIPS. So, no MIPS testing at this time. We do only test using a single version of GCC and single version of CLang. And there are not so much tests using different configure options, because each option to configure, each enablement or disablement of different modules will greatly increase build time. It will require additional set of jobs to be run. So, as I said, at the worst time, each commit, each pull request required for the developer to wait for 4 hours before he can see the results. Is that really a continuous integration? No. So now up to Maxim back.
So yeah, as was shown on previous slide, matrix is very big, and a lot of combinations of different configure options can result different code path, and we have to check that all this code path works. So and also we need to speed up our execution of CI as much as possible. So to do that, we use Travis feature. It's a cache. So we have a lot of dependencies, which is depends on ODPs depends on. It's like DPDK, CUnit, netmap, and whatever. So we built all of that only once and install it somewhere locally in Travis Cloud, and after that we reuse it. So after we enabled cache, just testing time decreased it at almost 2 times, because compile DPDK only takes about 20 minutes on single core. So other feature which we have automatically with GitHub, and we triggered the task from the Travis, is code coverage. So we use CodeCov project, and on each patch or change we also can have changes, and if we go to links to details, we can see how often each line of code was triggered. And if we just analyze some logs, when I did this presentation, I went through the code and I found that we have some functions which we do not use in the project, but we still it in the code, and there is no any reference to that functions. So probably we need to delete them.
Or to enable them in the tests, yeah.
Yeah, and also very useful to find some code path which we even do not touch, and it might be hard to see from review, but it's very easy to see when lines are highlighted and you see where the code was and what lines were executed. So I think next is...
Yeah, our future steps. We want right now we are just cross-compiling our code for different platforms. We would really like to cross-execute tests using the QEMU. There are plans or permissions by Travis and several other companies to enable Travis with a native ARM service. And we are working on further optimizations or further reducing build time, because even 2 hours is too much to wait. You cannot do that really continuously, you have to wait. So we are working on that.
Yep. Thank you. There are some links to ODP project, and as I said, you can reuse our experience. Just take a look at our configuration of the Travis and use it in your project. A link to the Travis, and if you want to know more about what is Open Data Plane and how to use it, please visit opendataplane.org website. Thank you. Do you have any questions?
Yeah. Thanks, Hanapa.
Thank you.
Okay, you were just two hands in a row. Sorry.
So, you know, obviously we've made very good progress in reducing the test time, you know, for doing the validation. What's your sense of what's a achievable goal? I mean, we're now at 2 hours. Could that get down to 20 minutes, or is that would that require paying money to get more servers?
I do not know about paying money. I didn't check that option, but we are trying to enable more and more caching. Right now, it's not only caching of the build artifacts like DPDK or netmap, it's also caching of the files that we have in our projects. Unfortunately, the significant amount of time that is used by testing is used by performance tests and actual testing frameworks. So there will not be a possibility to greatly remove this, greatly reduce this time, but we'll see what we can do.
Yeah. So performance tests, as Dmitry said, take a lot of time, and inside Travis, unfortunately, we cannot schedule the same test to be run on the same machine on some isolated environment to get very predicted and very exact results for networking. And so we just run validation test inside the Travis to validate that it functionally works. And probably if Travis will assist us to do better environment, or we can use our environment, so we move out performance test out this, and all of this testing stage and builds will be more fast than it's now.
I'm sorry, there was another question.
There was second.
Sorry, just a couple of observations. So the QEMU project uses Travis as well to as a CI system, although we have exactly the same problem with build times, so we tend to be more reactive. So it's more of a case of, it's broken, we can go back and find what broke it. For the cross-compilation, we had exactly the same problem with cross-compilation. So what we've actually done is we've got a bunch of Docker images that we use inside our build system, and then we run those on shippable. But that allows us to hit the entire cross-compilation range. So we do ARM, AR64, S390, or basically everything that Debian has a cross-compiler for. Oh, and Windows cross-compiles as well. So you might want to look at that.
Yeah, thank you. Yeah.
So I was just wondering, since the performance tests take the most amount of time, can we just skip those only when the pull request is approved or something like that? Because there's 2 hours or 3 hours of time, we tend to send so many updates on the pulls. And
as we said, this is work in progress because we are working on separating the different tests and checking what is really required to be run at the pull request time and what is not, and checking if we can skip some of the performance tests. So.
okay.
Yeah, performance test is not so simple question, because for now we have some different code paths for timer test and for our test. So if we know that we are in the test environment like Travis or Linaro CI, where timing is not predictable and core are not isolated, so several tests can go out of boundary. So it's not just exact rate for time, for example, or some expectation for packet flow. So probably we can just improve the test then to make it quick run for functionality, and even if it's a performance test, just to see that any new commit didn't break functionality, and to do big test with performance somewhere else.
Also, compared to the API test, that is the second major part of the test suite, performance tests are really complex tests. API tests are usually, or for some parts of the API, are just simple tries to execute simple tests to check that API is implemented this and this way. They do not fully execute and enforce internal code paths. They do not check all the possible versions of the code paths inside the implementation. So just disabling performance tests would result in a significant drop of, for example, code coverage during the test.
Actually, following up to Vala's question, does Travis allow the tests to be organized in stages such that, you know, when I submit a PR, I run a quick set of basic tests, and only if those pass do I then go on and do others, because if the basic ones fail, I know I'm going to have to resubmit the PR anyway.
Yes, there is they added such a possibility when they added the jobs include these one-by-one addition of jobs. It is possible to split the test suite into separate build stages. We tried looking into that, and in fact it increased build time, because next stage will not be executed till previous stage completes. For now, if you check the build matrix, can you click build? Again, you will see that there are some tests that are taken, in this case 10 minutes, because this is already after enabling of all the caches. And for example, cross-compilation tests take only 2.5 minutes. So if you break compilation in this or another kind, you will see quite soon that, okay, it's broken.
Maybe having the checkpoints running alone and then all the others would make sense?
Maxim?
Maybe just running the checkpoints before the checkpoints test before running everything else would make sense, because we did have failures on that.
We can reorder the tests, so
Okay.
It doesn't matter which test will be run first. So,
well, if the checkpoints fails, there's actually no need to run anything else until the patch is resubmitted.
Well, it's depends. If check patch fail, that it doesn't mean that your all continuous code is right. So you can correct alignment on some if statement, and at the same time you can correct a bug which will appear in some other place. So I do not, at least my opinion, there is no any reason to just fail all the build if check patch fails. You have to see all the picture, that all the test pass.
Exactly, because check patch is useful, code style is great to have and to follow, but sometimes check patch fails due to this or the other reason, because, for example, CUnit is using camel case, and so when we are calling into CUnit, there will be camel case in our code. There are, of course, some requirements on using the alignment of inside the code, and sometimes this just does not work good enough, and to be a better say, okay, this does not follow the code style guidelines, but still this is better than following it blindly. So this is only a one-off test, and in fact it's a minor test, not the important one.
So our test suite can actually run in parallel. So have you done that already? Like, let's say classification, packet IO, pool can be run in parallel, need not be run sequentially. I know, like, we don't have the framework, but can it be done optimized like that?
For some time we had enabled make -j for make check running tests in parallel, and sometimes they have side effects because some of the tests will take too much CPU power, or will produce results that make other tests fail. So right now we are not using any parallel execution of tests inside each of the jobs. And if you are talking about adding, for example, one job for performance test, one for API validation, and one, for example, for examples, I don't think that will be a good idea, because actually for each of the tests you will have additional delay of setting up the container, setting up environment inside that container, downloading packages from the net, etc. And this also takes time. So we are trying to find the really good balance between amount of jobs, amount of options that we are trying to test, because we would like to add more jobs, really more tests and more features to test. And at the same time, the balance, again, of the amount of the jobs, because each additional job, each additional test configuration adds a lot of time with overhead on setting up this container.
So just for my understanding, so this 1 to 20, do they run in parallel or they run one after the other?
Travis is running up to 5 jobs in parallel.
Okay.
So, 5 testing jobs, 5 test containers. And if I remember correctly, each of these containers uses 4 virtual CPUs.
Yeah, so all time in execution, it's about 2 hours, but because of we run parallel these tasks, it comes to 20 or 30 minutes, something like that.
So since we are an open source project, does it mean like we have a limited amount of processing? Let's take I have 5 branches and all 5 are compiling running at the same time. If I kill some of the builds, will it go faster, or it's like it doesn't matter how many builds I run?
If I'm, for example, checking that this change will only, if I did some change only, for example, for ARM64, I can go to the web interface and use one of these buttons to kill jobs that are not required for this test.
Yeah, actually, this is cancel button, so you can click to buttons which you don't want to run at this time, or you can
rerun the job.
Rerun the job.
And as we discussed, Dmitry and myself, so can we enable this only for selected branches? Currently it runs for all the branches, right?
If I remember correctly, it's enabled for all the branches. I really have to check the documentation. After you asked, I checked the docs, but I had only a few minutes and I couldn't find such config option. Basically, my feeling is that I myself would not like to disable whole testing for any of the branches, because even if I know that it will fail, it's better to have tests marked as failing rather than to forget the test for one of the branches and after that find that it was really required. So
yeah, actually for upstream project we use all branches, but if you for your own fork on GitHub you want to select some branches, you can just log into Travis web interface and in configuration select what to test.
Oh, okay. So I can go to the config and then select what are the branches.
Yeah.
Oh, that's interesting.
Okay, any more questions? So, thank you. If there will be any more questions after that, just drop Maxim and me an email and we will try to answer from our experience. So, thanks.